Alright, beginning with our first example, this is an I do. So it's very similar to what we did on Friday on 3.10 on Best Fit Day 2, but I will review some of it. Christian recorded the data of the time his phone was being charged and the battery percentage. So here on this chart, the x-axis is time charged, and on the y-axis is battery percentage. So it looks like there's a positive correlation. That means it's going to have a positive slope. That should mean, and it makes sense, that the longer he has his phone charged, or the more he has his phone charged, the more his battery power goes up. So it's the first one that they asked is to write the equation of the line of best fit using 2 points, 13,9 and 20,17.5. Just right off the bat, I like to label it so I don't get confused. So this is x1, y1, x2, y2. And this will take a little bit of work, so I'm going to work on this side. So in order to write the equation, we need to write in the format of y equals mx plus b. So coming back, I need to find what m is. M is the slope. So for this problem, the slope m is equal to y2 minus y1, so it's 17.5 minus 9 all over 20 minus 13. So on the bottom we have 7, and on the top we have 8.5. And using my trusty calculator, I have 8.5 divided by 7. And this should give me 1.21. And to keep it consistent, since this has 3 significant figures, I'm going to keep 3 on the slope. So my m is equal to 1.21. What does this mean? What does this number mean? That means that for every 1 minute, my phone battery is going up 1.21%. So there is my m. So after you find your m, you need to find your y-intercept. So on your y-intercept, let's go ahead and let's plug in this point because it doesn't have decimals. So my y is going to be y is 9. Is equal to my m is, as I found earlier, 1.21. Parentheses, my x is going to be 13 in this case, plus b. I'm going to go ahead and multiply these two. 13 times 1.21 gives me 15.73, but I'm actually just going to keep it at 15.7. So I have 9 is equal to 15.7 plus b. Now I'm going to subtract both sides in order to solve for b. Minus minus, and b is equal to 9 minus 15.7. This gives me negative 6.7. So if my final equation with the b and the m plugged in, I have y is equal to 1.21 x minus 6.7. And there's this, so this equation represents this line of best fit. There is the first part of the problem, finding the equation of the line of best fit. So let's do some interpolation. Remember, interpolation is that we're trying to predict a data value from within these data that we have. It's what we see in front of us. So for this one, we're going to find a battery percentage at 11 minutes. And we're going to round our answer to the nearest whole number. So at 11 minutes, that means my x is going to be 11 minutes. So I can go ahead and plug in this x into my equation that I found earlier. And I have y is equal to 1.21 parentheses 11 minus 6.7. 1.21 times 11 gives me 13.3 minus 6.7, and that gives me 6.6. So what does this mean? What does 6.6 mean? That means that at 11 minutes, my phone percentage should be at 6.6%. Let's just double check with our graph. Let's see if it makes sense. So here at 11 minutes, here's 10, here's 12. Here at 11 minutes, if I'm right here on my graph, It should be around, it's close, it's around 8. So it's close, it's a little bit off, but it's somewhere around the vicinity. Alright, so now let's extrapolate. Find the battery percentage at 25 minutes. So the reason this one is extrapolation is because our data point only goes from 4 to 20. So when we extrapolate, we're trying to predict the value out here that's outside of the current data points. So at 25 minutes, x is going to be equal to 25. That means I can plug it into my equation. Y is equal to 1.21 parentheses 25 minus 6.7. I'm going to put that into the calculator. 1.21 times 25 minus 6.7. And my battery percentage Y is going to be equal to 23.6%. So it's saying at 25 minutes, my battery percentage should be at 23.6%. Hold on. So now let's check up here with our, I guess we can't really check with our graph, right? Because it goes outside of the data points, but that sounds about right. At 25 minutes, my battery percentage will be at around 23.6%. That sounds pretty realistic. Ooh, bonus question. How long would it take to charge this phone to 100%? So problems like this 100% is actually my Y value. So my Y is equal to 100. So now I'm going to plug my Y back into this equation on top that I found earlier that represents this situation. My Y is going to be equal to 100, so I have 100 is equal to 1.21 x minus 6.7. So now I have to solve for x because it's asking me how long. That means I need to find x. I need to find how long it's going to take for me to get my phone to 100%. So here I'm going to add, in order to solve for x, I'm going to move over to 6.7. I have plus 6.7 plus 6.7. That gives me that gives me 106.7 is equal to 1.21x. Now I'm going to divide both sides by 1.21 to get x by itself. Sorry, I'm running out of space. So I have x is equal to, let's chop this off. I have x is equal to, going to put it into my calculator, 106.7 divided by 1.21, 106.7 divided by 1.21. That's x is going to be about 88.2. 88.2 minutes. So answering the question, how long would it take for his phone to charge up to 100%? 88.2 minutes. That is going to be my answer, but that's hard for you guys to actually process. So I'm going to actually turn it into 1 hour and 28 minutes. So it's going to take me 1 hour and 28 minutes to charge my phone all the way up to 100%. Awesome, thank you for watching. Try the next redo before you watch the next video, please. Thank you.